Hello and welcome to my YouTube channel. This is Dramani Online Mathematics. Today we want to look at homogeneous differential equation. We have already looked at homogeneous functions and we have seen what a homogeneous function is. Now let's look at homogeneous differential equation. Then we proceed to look at the solution to the homogeneous differential equation. So let's look at the definition. A differential equation of the first order dy dx equals f at xy is called homogeneous differential equation. So this side is homogeneous differential equation in x and y if the function f at xy is a homogeneous function of degree 0 in x and y. So all the homogeneous functions that we solve, we're having those with degree 1, degree 2, degree 0, degree 3, okay? And before you can say that something is a homogeneous differential equation, then that function or that homogeneous function must have degree 0, okay? So now let's look at some examples that fall under this. So now let's look at these two examples. We should verify which of these two examples is homogeneous differential equation. I've already said that for it to be a homogeneous differential equation, it must be a homogeneous function, and that function must have a degree 1, okay? If you have forgotten the definition of a homogeneous function, we said that for a homogeneous function, lambda x, lambda y is always given as lambda x, y, okay? So let me put n here, so that the n is the degree. Okay, so now let's pick the first example. We have y prime equals t minus y over t plus y. So per the definition, we know that this y prime can also be written as dy dx, okay, in terms of t, so dt equals t minus y over t plus y. Is that okay? So what you are going to do is that you are going to replace one. What you are going to do is that you write this one in terms of lambda t lambda y, and that one means that wherever I see this, I'll put lambda t minus lambda y, all divided by lambda t plus lambda y. So with this, we are going to have f lambda t lambda y to be equal, so this lambda and lambda come out. We have lambda bracket open t minus y, all divided by lambda out t plus y. So you realize that lambda t lambda y is going to give us, the lambda will give us lambda to the power 0, because this and this is power 1, is power 1. So when I send this one top by indices, this will give us 0, and this will give us the function which is t y. So now that you have the function, the lambda to be degree 0, that is n is equals to 0, then we can conclude that this is a differential equation, because we are having a degree of 0. Once that the degree is 0, then you can conclude that it's a differential equation. But if you have something that the degree is not 0, but rather 1, 2, 3 or more, then it cannot be concluded as homogeneous differential equation, but it can be a homogeneous function. So we can say that all homogeneous differential equations are homogeneous functions. Is that okay? But not all homogeneous functions are homogeneous differential equations. So now let's look at the other example you see. So the next example we have dy dx equals, this is t, so let's take dt cos t sine t over y. So with this one, I'm going to replace this one by the function of this. So lambda t lambda y. I'm just going through. So this side will give us lambda t sine lambda t lambda y. And this will definitely give us lambda t lambda y lambda t sine ty. Well, this one will give us something 0. But still we have a lambda here. This one will give us lambda to the degree 0. And so that will go. So we have a lambda here. This lambda is power 1. So the degree there is 1. So this is a homogeneous function, but what? Not homogeneous differential equation. So you see the difference. So since the power of the lambda here is more than 0, then it cannot be concluded as homogeneous differential equation, but it is homogeneous differential function. So we can only say that something is homogeneous differential equation when you are having a degree of what? 0. Okay, now let's look at the solution to homogeneous differential equation. We can only solve that when that happens. Alright, so let's look at the solution to the homogeneous differential equation. And we said that homogeneous differential equation of this dy dx equals f of xy can be transformed into an equation of separable. You know that the homogeneous functions are functions that is not separable. You can't separate them. Okay, so before you can solve homogeneous differential equations, you have to be able to separate them. And what can help us to separate them is to use a transformation y equals ux. So this one will help us to transform the homogeneous differential equation to a separable one. So now let's look at how this thing is done. So let's look at an example. So okay, now let's look at this example. Now we have this example on the board. Please, in exams, nobody will tell you that whether it's a homogeneous differential equation or a separable, but you have to be able to know. But just at glance, you realize that this one can never be separated. So we use the homogeneous differential equation, and we said that for that one too, the lambda must have what? Degree 0. Okay, so first thing, let's check whether the lambda is having a degree 0. Is that okay? Good. So I can write this one as f of lambda x lambda y equals, so wherever I see x is lambda x, wherever I see y is lambda y. So I'm going to have lambda x lambda y, all divided by lambda x squared minus lambda y squared. Is that okay? So with this, lambda times lambda will give us a lambda squared, then xy, all divided by lambda squared x squared minus lambda squared y squared. Is that okay? So with this, I can factorize the lambda squared out, and when I do that, I have lambda squared xy all divided by lambda squared out, which will give you x squared minus y squared. I hope this is okay. Good. So from here, you realize that we are having f lambda x lambda y to be equal to lambda to the power 0 f of xy. So since the n here is 0, the degree is 0, then we can say that this is what? Homogeneous differential equation. Therefore we can solve it. Now let's see how we can solve this one. Now, before we start, I've already told you that before you can solve homogeneous differential equation, you need to use the transformation. So there's the transformation. Y is equals to what? Ux, okay? So for the y equals to ux, what you're going to do is that you're going to substitute this one into the equation that was given to us. So we have dy dx equals, wherever I see y is ux, so this one becomes ux, all divided by x squared minus ux squared. Is that okay? So from here, you realize I have dy dx equals x times x is x squared, and here to have x squared here. So when I factorize it out, I'll be having u over 1 minus u squared. Is that okay? You check. When you factorize out, this is what you're going to get. Good. Now at this point, this is what I have for dy dx. But this dy dx here does not correspond to this. This is u in terms of u, and this is with respect to x, so it does not correspond. So you go back to the transformation. Let me name it, let's say equation 1. Then we differentiate this one. So this will give us dy dx equals, now this is product rule, so I hold the u, then I'll differentiate x. If I differentiate x, it will give me 1. 1 times u is u plus, now I'm going to hold the x, then differentiate u. That will give me x du dx. Have you seen that? Now, after getting this, let's name this one equation 2 and this one equation 3. You realize that equation 2 and equation 3, they are all having dy dx. So we can say that dy dx is equals to dy dx. So we can have u plus x du dx to be equals to u over 1 minus u squared. Can I have something like this? Yes, because that's when you equate the one equation 2 and the equation 3. Good. Now let's clean this side. Okay, so now this is what we have. X du dx is equals to u over 1 minus u squared minus u. So now this is what we have here. Now, by looking at this particular one, you can find LCM. So by doing so, we have x du dx equals u minus u plus u cube, all divided by 1 minus u squared. What you find out, and that's what you're going to have. So this will definitely go with this. So we have x du dx equals u cube over 1 minus u squared. So this is what we have. Now, if you look at this particular one, you can now separate it. So you see the transformation y equals ux has able to transform this one into a separable one. So we are going to put all the u's at where the du is and the x2 at where the dx is. So by doing that, that is very simple. We are going to have 1 minus u squared all divided by u cube du equals to dx over x. When you separate this one, this is what you get. Is that okay? Now, looking at this one, we need to integrate this one. So how do you integrate it? just bring the integral sign here. But this one I can separate it by writing it as integral of 1 over u cube du minus integral of, no, u square over u cube will give us 1 over u du equals integral of 1 over x dx. So when I integrate this one, I'm going to have negative 1 over 2u squared minus ln u equals to ln x plus ln c. So this is what you are going to have. For the integration, please. Please, for the integration. So for the integration, you realize that this is 1 over u cube. You have to send the u cube top, then you do the integration. This is a function derivative, so this is what you get. Very good. Now, we are not done. Ln x plus ln c can be written as ln cx, right? So, here's what I'm going to have. Negative 1 over 2 u squared equals ln cx plus ln u. I'll send this one to this side. Good. So this one I have. So this 3 can be also be written as ln c xu or cux equals negative 1 over 2u squared. So looking at this one, what do we have? In the question, they did not give you any u. It was in terms of y and x. We just do the transformation. So from equation 1, where you have y equals ux, you can make u the subject by having y over x. So wherever I see u, I'll put y over x there. But remember, if I put y over x here, the x will cancel this x. So I'm going to have ln c y equals negative 1 over 2 y squared over x squared. Okay, this one you can rewrite it all so that the x squared will go top. So this will be our final answer. Somebody can decide to take e on both sides so that the ln will go, leaving cy. Okay, this is what I'm trying to say. Now, this is what I have here. This is what I have. So I can write this one as cy equals negative x squared over 2y squared. Is that okay? So you can take e on both sides so that you have cy equals e to the power negative x squared over 2y squared. So this one becomes your final answer. Now let's look at an example 2. Example number 2. Now solve the differential equation, this one. You want to find the general solution. Once there's no initial conditions given, so it's always general solution. Now looking at this one, the idea is that you have to be able to write this one in terms of dy dx. Is that okay? You have to write it that way first. So let's see. So dy dx first. So first thing, I can write this one as 2x cubed y dy equals negative x to the power 4 plus y to the power 4 dx. What has happened? I just send this one to the other side, then it becomes negative. Now, because I want to write it as dy over dx, I just divide here by dx. So when I do that, I have dy dx. And here, let with this one, which is negative x to the power 4 plus y to the power 4. Then divide by this one, which is 2x cubed y. Have you seen that? So I've rearranged the thing. But what happened here is that you have to test whether it's homogeneous differential equation. So if I test, you realize that it will be, because here we lambda power 4, lambda power 4. If I bring the lambda power 4 out, and here will be lambda power 3 times lambda. That will be lambda power 4. If I bring that one 2 out, it becomes power 0, because lambda power 4 by lambda power 4 will be lambda power 0. So that one is work done. So now that we have seen that it's differential homogeneous or homogeneous differential equation, then we use a transformation where you say that y is equals to ux. Is that okay? So let's name this one equation 1. Now we have dy dx equals, so I'm going to put the transformation there, which will give us negative bracket would be x power 4 plus u power 4x power 4, all divided by 2x power 4 multiplied by ux. Just that wherever I see y, I put ux there by using the transformation. Okay, so now from here I have dy dx equals x power 4 coming out. So I have 1 plus u power 4 all divided by this one x, sorry, this is power 3 because it's s cube here. Okay, so power 3 times this, that would be x power 4. So I can also bring that one out, leaving 2u. Okay, so this and that will cancel. So when that cancels, we have dy dx equals negative bracket will be 1 plus u power 4 all divided by 2u, because this one will go with this. Good. So now that we are done with this, as I said, it's not right that dy dx equals to something in terms of u. Suppose dy du. So we have to come back to the transformation. So let's name this one equation 2. Let's come back to the transformation. So the transformation is y equals ux. So we need to differentiate this one. So that will give us dy dx equals u plus x du dx. This is a product rule, okay? So name this one equation 2. And we are saying that if you look at it, we have equation 2, sorry, this is equation 3. Equation 3 and equation 2, they are all having dy dx, dy dx, so we can equate them. So by doing so, we can say that u plus x du dx equals to negative bracket open 1 plus u power 4 all divided by 2u. So this is what we have. Nice thing, nice equation. So okay, now let's try to do the separation. So let me send the u to this side first. Okay, good. So I have x du dx equals negative. Let me multiply the negative through. So that's going to be negative 1 minus u power 4 all divided by 2u minus u. So here I find LCM, and that gives you this negative 1 negative u power 4 minus 2u squared all divided by 2u. So this is what I'm going to have. Now these are all negative, so I can factorize that one out. So that will give us negative out, and this one will be 1 plus u. So let me write this way: 1 plus 2u plus u power 4, all divided by 2u. And this one can also be written as x du dx of negative bracket open 1 plus let me put this way, u squared, okay, yeah, all squared divided by 2u. You can write it like this. This one, if you expand this, you get this. Good. So now at this point, let's separate it. So look at, I want all the u's to come here, then the x will go here. So these 2u will multiply this over this. Then here will be the x over x. I'm writing it straight. So I'm going to have 2u du over negative 1 plus u squared is equals to the x over x. This is how you are going to have. Okay, let me maintain the negative here. Is that okay? Good. So at this point, we integrate. Let's see how we are going to integrate this. It's very easy to do the integration, but if you don't take care, you find yourself wanting. So please, what I can say is that those that don't know much about the integration, you can use the u sub, where you have to represent here by something. But I'm going straight. So if I integrate this one, I'm going to have 1 over negative, okay, 1 over 1 plus u squared. I think that will be, because you represent here by something, let's say x. So if you integrate this one, or if you differentiate what is here by the x, that will give you 2x, or let's say 2u2. That one will cancel this one. So when it comes, we have this. So this side becomes negative. Yes, we have negative here, and here will be 2. There must be 2 here. Yes, it must be like this. It's equals to negative ln x plus ln c. So this is what you're going to get. Yes, this is how you're going to get. So at this point, I can write this one as ln c over x is equals to negative 1 over 2 bracket 1 plus u squared. So that's the integration there. Would there be any 2 here? Let me clean the 2. Let me show you how I integrated this one. We have something like this: 2u over 1 plus u squared, then all squared du. Okay, my marker. So we said that let's say x to be equals to 1 plus u squared. Okay, I'm just showing how you integrate this one. So this side will become dx equals 2u du. Though that when you integrate, differentiate this one will give you 0. So now from here, we want to make du the subject. So I'm going to have du is equals to dx over 2u. So now let's come back to this place. Now what do we have here? We have 2u over, the whole of this one is now x, but there's a square there because you said that 1 plus u squared should be equals to x, and there's already square there. And this du is now dx over 2u. So then this one will cancel this one. So what do we have here? We have the integral of 1 over x squared dx. So that's what I was talking about. So looking at this one, if I integrate this, I'll have negative 1 over x. Negative 1 over x. So, and the x is this 1 plus u squared. So that's what I had here. Negative 1 over 1 plus u squared. So that's why I do the integration. Good. But that one is not part of what I'm doing. I just wanted to show you how you can integrate these ones. So now that we have this, ln c over x is equals to negative 1 over 1 plus u squared. Please, the arrangements, maybe you can see a similar or the same question somewhere, and the x will be the top and the c will be down. It doesn't matter. This is a general solution. When they give you initial condition, you see that when you substitute the initial condition there, no matter how you have been arranged your work, it will still give you the same answers. So it doesn't matter whether you see that the x will be top or this c will be down. That way it doesn't matter. Good. So now looking at this one, we said that y is equals to ux. Means that u will be equals to y over x. So you have to transform back. So I'm going to have ln c over x equals negative 1 over 1 plus y squared over x squared. So we have ln c over x equals negative 1 over x squared plus y squared, all divided by x squared. You know that this one you can find LCM. So this one also can be written as negative x squared, all divided by x squared plus y squared. So ln c over x equals to this. And that is the final answer. It's general solution. So when you see the c there, there's no problem with that. No cause of what. Now, thank you very much for watching. Please try to subscribe, share to your friends, and practice. Yeah, practice is very important. Practice more questions, you understand. Thank you very much. Please